Hi, this is lesson 2 for the AP Calc summer assignment. We're going to talk today about 3 different ways of evaluating limits. So the first way is direct substitution, the second way is the dividing out technique or factoring technique, and the third way is the rationalizing technique. Remember last class we looked at limits and how the left and right hand side must be equal in order for a limit to exist. So today we're going to look at 3 algebraic ways of determining if a limit does exist. So the first way is just basic substitution. So if you think about this equation, 2x plus 1, it's a line that starts at 1 and has a slope of 2. So it goes up 2 over 1, up 2 over 1. It's a nice straight line. So obviously the limit at any point, including 5, is just going to be the value on that line because the left and right hand side is approaching that y value on the line. So I can simply plug in 5. So 2 times 5 is 10 plus 1 is 11. So we know that as x approaches 5 from the left and as x approaches 5 from the right, the limit will be 11. Same thing in the next one, I have x to the 4th, which is kind of like a really steep parabola looking thingy. If we plug in 7, 7 to the 4th is 7 to the 4th, and in AP Calc that would be an acceptable answer in the no calc part of the test. You could also do 7 to the 4th in your calculator. Alright, so let's think about this one. This is really the equation y equals 5. So that's a horizontal line at 5. So we have a horizontal line at 5. So the question is, what's the limit as x approaches 0? Well, if we go from the left, it's getting close to 5, and if we go from the right, it's getting close to 5, so the value must be 5. This is really, the equation y equals 5, so no matter what x is, y is 5. So our answer there will be 5 using substitution. We look at example 4. The cosine graph, hopefully you remember from trig, looks sort of like this. It starts at 1, it goes down, and that's our pi right there. But either way, it's continuous. So as it goes to the left and as it comes from the right, it's getting close to the same value. So if you plug pi in, the cosine of pi is -1. No. Yeah, the cosine of pi is -1. I just messed that up. Let's look at that graph again. So the graph of cosine starts at pi at 0, hits there at pi over 2, there at pi, there at 3 pi over 2, and we go back at 2 pi. So our pi value is that -1 value. Sorry that I messed that up a second ago. Alright, so let's look at our next example. For number 5, we could just directly plug this in. So we have 5 times -3 squared minus 10. -3 squared is 9, so 5 times 9 is 45 minus 10 is 35. Notice how I did not use my calculator. Start getting in the habit of not using your calculator. Why don't you pause me and go ahead and try 6, 7, and 8 and see what happens. Alright, you should have paused me and you should have come back and you should have answers. The answer to number 6 should be -1 because the sine of 3 pi over 2 is -1. The answer to number 7, if you plug 1 in, you have 1 squared plus 3 times 1 plus 4 over 1 plus 1. So we have 8 over 2, which is 4. There's no problem with plugging 1 in because it does not make the bottom of that fraction 0. 1 plus 1 is 2. That's okay. Then we plug in number 8. We have -2 squared, which is +4, minus 12 is -8. So just direct substitution there is great. Alright, let's look at the next one. The problem in the next one is we cannot plug -3 in because if we plug -3 in, it makes our bottom 0. And we're not allowed to divide by 0, so that doesn't work. However, if you were to look at that in your calculator, remember, if you actually factor that, you have x plus 3 and x minus 2. And we already have an x plus 3 on the bottom, so that's actually a removable discontinuity. If you were to look at that in your calculator, feel free to look at it in your calculator, it would look something like this. But when x equals 3, you'll have an open circle. So although there's an open spot at 3 because it's undefined at 3, there is still a limit there. So as we're going to the left and as we're going to the right, we are getting close to the same number. So if I cancel those out, if I divide that out, I can then plug in negative 3. Negative 3 minus 2 is negative 5. Did I screw up my graph? Am I having a bad graphing day? Oh, silly me. Hold on a second. I was looking at positive 3. If we were to look at negative 3, that would be our open hole. And that does look like it would have a y value at negative 5. All right. So if we look at the next one, number 10. Well, if you know how to factor perfect cubes, you can factor the top of that. But let's be honest, I don't remember how to factor. If you remember how to factor using synthetic division, you could factor that using synthetic division or divide that using synthetic division. Since most of us aren't going to remember that, and since we need long division later, I'm going to divide using long division. So I have x cubed plus 0x squared plus 0x minus 1. I'm going to divide x minus 1 because that fraction bar really just means divide. Up in problem number 9, I really just divided x plus 3 and x plus 3. It was division. So I asked myself, how many times does x go into x cubed? Well, x squared. Then x squared times x is x cubed. X squared times negative 1 is negative x squared. I subtract. 0 minus negative 1 is 1x squared plus 0x. And now I say to myself, how many times does x go into x squared? Well, 1x. 1x times x is x squared. 1x times negative 1 is negative 1x. We subtract. 0 minus negative 1 is 1x minus 1. And I say, how many times does x go into x? 1 time. So 1 times x is 1x. 1 times negative 1 is negative 1. We subtract, we get 0. So when we divide this out, we know we're really looking at the limit as x approaches 1 of x squared plus x plus 1. We couldn't plug it into the original equation because it made the bottom equal to 0, but we can plug it in now. We have 1 squared plus 1 plus 1, so 3. If you don't remember how to long divide, that's something you need to look up. Look it up on Khan Academy or find a way of learning how to long divide soon. Alright. The other method, hopefully you remember this method from pre-calc, is rationalizing the numerator or denominator. So basically, if we look at this square root function, we cannot plug 0 in because 0 makes the bottom, or 0 makes the denominator 0. We can't divide by 0. So I have to rationalize this fraction. So what that means is I take the part with the square root and I multiply it by the same exact thing, only I change the sign in the middle. So instead of minus 1, I put plus 1. And I have to do that on the top and bottom because what I'm really multiplying by is 1. Since I have the same thing here, this something divided by itself is really 1. So then I multiply. We have the square root of x plus 1 times the square root of x plus 1 is x plus 1. This is the square root of x plus 1 times 1. And negative 1 times the square root of x plus 1. And negative 1 times 1 is negative 1. It's all over x times the square root of x plus 1 plus 1. And you never need to FOIL the bottom part. It doesn't really matter. We still have that limit that we don't want to forget about. We don't want to lose it, so I'm going to keep rewriting it. And the cool thing about this, if it's done correctly, the outside and inside term always cancels out. Then typically, the numbers will also cancel out. So we have x divided by x times the square root of x plus 1 plus 1. And hopefully you notice right away that the x's simplify. X divided by x is 1. And that has to go on top because you can't move something from the bottom to the top. So square root of x plus 1. And then we can finally plug in 0 for x. So if we plug in 0 for x, I have 1 over the square root of 0 plus 1 plus 1. So 1 over 2. So the limit as x approaches 0 is 1/2. All right, next problem. We're going to evaluate this one as x approaches 3. I would recommend that you take a couple minutes, you pause this one, and you try it on your own. All right, you should have paused me. I'm going to go ahead and go over this one. So we're going to multiply by the square root of x plus 1 plus 2 over the square root of x plus 1 plus 2. So we have square root of x plus 1 times square root of x plus 1 is x plus 1. The outside and inside is going to cancel, so I'm not going to write it. Negative 2 times 2 is negative 2. At the bottom we have x minus 3, and we have x plus 1 plus 2 on top. All right, awesome. So now 1 minus 2 is negative 1 minus, wait a second. I'm making all sorts of mistakes today. Negative 2 times positive 2 is negative 4. 1 minus 4 is negative 3. On the bottom we have x minus 3, and then we have the square root of x plus 1 plus 2. So, notice this one works really cool because the x minus 3's cancel out. And we have 1 over the square root of x plus 1 plus 2. We can plug our 3 in. So it's 1 over the square root of 3 plus 1 plus 2, which is 1 over 2 plus 2, which is 1/4. So that's our limit there. All right, before we go any further, I want you to try these two. I'm going to just go ahead and show the work, but pause it, try these two, make sure you're good with these. If you're not good with these, you maybe need to watch somebody else teach this or find a friend to help you, and then we'll move on. All right, so I'm going to go ahead and do this problem. So we take out 2x squared because they have a 2x squared in common. That leaves us with x minus 1, which is miraculously what's on the bottom. So they simplify. We have 2x squared. I can plug in the 1 finally, so it's 2 times 1 squared, which is 2. In this problem, you're going to multiply by you're going to rationalize this fraction, so you have x plus 3, or x plus, the square root of x plus 5 plus 3 on the top and bottom. So square root of x plus 5 times square root of x plus 5 is x plus 5. The outside and inside is going to cancel. Negative 3 times positive 3 is negative 9. We have x minus 4 times the square root of x plus 5 plus 3. So we know that 5 minus 9 is negative 4. So we have x minus 4 over x minus 4 times the square root of x plus 5 plus 3. So the minus 4's cancel. We have 1 over the square root of x plus 5 plus 3. And we have to plug 4 in because we have to evaluate the limit as x approaches 4. So 1 over the square root of 4 plus 5 plus 3 is 1 over 6. All right, so we've covered three methods at this point: substitution, factoring, rationalizing, and then there's one other thing we have to worry about if there's a fraction. So this is really just getting a common denominator. So we're going to multiply this fraction by 2 and this fraction by 2 plus x. So on top, I now have 1 times 2, which is 2. This is really negative 1, so negative 1 times 2 and negative 1 times x. And I have 2 times 2 plus x. Now don't forget I have this x here, so I'm still dividing by x, which is really x over 1. So remember back, we know 2 minus 2 cancels out. And remember back to 5th grade or so, to divide two fractions, I really keep the top one the same. So I'm going to keep that piece the same, and I flip the bottom fraction, so that's 1 over x. So my x's cancel out, because I have 1 on top and 1 on the bottom. I'm left with negative 1 on top, and 2 times 2 plus x on the bottom. And I can finally plug my 0 in for the limit. So I plug my 0 in for x, so I have 1 over 2 times 2 plus 0, which is 1/4. So my answer on top is 1/4. I'm going to do the same thing on the bottom, but I would recommend that you pause me, check your answers, and come back. All right, so in this problem, this fraction needs a 4. This fraction needs an x plus 4. So now I have a common denominator in both top fractions. So on top, I really have 4. The negative 1 times x is negative x. Negative 1 times 4 is negative 4 over 4 times x plus 4. On the bottom, I really have x over 1. So I know I can flip that and make this 1 times 1 over x. So now my 4's cancel. And I know I have an x on top and an x on the bottom. Now that order matters. The 4's cancel first, the x's cancel second. So I have negative 1 over 4 times x plus 4. And now I can finally plug my 0 in. So I know it's the limit as x approaches 0. So I plug my 0 in. So it's negative 1 over 4 times 0 plus 4. So negative 1 over 16. All right, that was the end of lesson 2. You should now try the section 2.1 worksheet. At the beginning of lesson 3, I will give you the answers to that worksheet. Make sure you show your work. You will not get full credit unless you have work. So have a lovely rest of your day.